Find the shortest subarray that contains all values of a required multiset with multiplicities in linear time. Given an array A and a required multiset are with counts, the goal is to find the minimum length subarray of A that contains every element of R at least as many times as required. We'll walk through an example and build the sliding window intuition. Here is the array on one row as little boxes, with index labels below. Underneath, a compact table shows, for each required value, the number we need, and how many we currently have in our window. The missing counter starts at the total required count. We'll move 2 pointers left and right, and a purple rectangle shows the current window. We expand the right pointer to include elements and update the have counts. When we include a required value and the count does not exceed the need, the missing counter goes down. First, include index 0, then include 1, then 2, then 4. Now include index 8 to complete the coverage. At that moment, missing reaches 0, and we have a covering window. When missing is 0, we try to shrink from the left while the window still covers the multiset. If the left value is either not required or we have more than needed, we can drop it and move left forward. Drop index 0 because we have an extra 7. Drop index 1 because we have an extra 5. Now index 2 is a 9, and we have exactly 1 9, so we stop. The minimal window for this right pointer is from index 2 to index 8. Next, move the right pointer further to index 9, a 9. Since we now have an extra 9, we can shrink from the left. Move left past index 2 and past index 3, which is not required. We stop at index 4 because we need 2 2s. The new window is from 4 to 9 with length 6, so best becomes 6. Continue to index 10 and 11. At 11, we add another 2, allowing us to drop the leftmost 2 at index 4. But the window length then is 7, not better than 6. So the best remains 6. The final answer for this example is the subarray from index 4 to index 9, inclusive. It has length 6 and contains 2 2s, 1 5, 1 7, and 1 9. Here is the high-level algorithm. 1. Build the need counts for the multiset and set missing to the total required multiplicities. 2. Expand the right pointer from left to right. When we include a required value, if the have count does not exceed the need, decrement missing. 3. Whenever missing is 0, repeatedly advance the left pointer while the window still covers the multiset. Each element moves at most once or twice, so the total time is linear. Complexity. Each index enters the window once when the right pointer moves, and leaves the window at most once when the left pointer moves. Therefore, the total number of pointer advances is at most 2n, so the algorithm runs in O of n time. This sliding window method with multiplicity-aware counts gives a minimal covering subarray in linear time.